Air receivers. Air vessels or tanks are used to store compressed air before it enters into the piping system or equipment. Simply it acts as a buffer mechanism between compressor and endpoint where compressed air demanded, and without it, loading and unloading cycles can increase on compressor, making the compressor work harder. Explosion is the main hazard if safe working pressure has been exceeded or because its failure to withstand pressure through corrosion fatigue or internal coke fires. You can control the risks by preventing exceeding safe working pressure by properly designed and constructed to withstand the compressor's maximum pressure safely. Fitting safety valve and pressure reducing valve. Safety valve must be suitable with working system and complying with standard, capable of discharging more air than the system can supply. Install accurately calibrated air pressure gauge with a readily visible appropriate scale reading. Technical details should be clearly visible and marked on the vessel. Drain valve, safety valve, examination holes and manholes need to be accessible. It is required to fit fusible plug when using large compressor systems. It is recommended any welding works to the air receivers being done by manufacturer to ensure complying with the specification and approval of manufacturer. Must be cleaned and examined at regular intervals. Frequent examination contained in a written scheme and examination drawn up or certified by competent person. Coolers. Mechanical heat exchangers used to remove airflow heat and moisture to produce suitable cool and dry air for use in air-powered equipment. Many aftercoolers are pressure vessels and the associated hazards are similar to those of air receivers. So explosion is the main hazard if safe working pressure has been exceeded or because its failure to withstand pressure through corrosion fatigue or internal coke fires. You can control the risks by good circulation of external air over the heat exchanger surface to ensure effective transfer of heat, adequate space available around these heat exchangers to allow effective cleaning of all surfaces, install automatic drain valve, provide protection against freezing of the valve, monitor and measure inlet and outlet temperatures of the compressed air and of the coolant. Cooling air inlets and outlets should not be obstructed by loose equipment. Ensure cooling circuit protected against corrosion and provide coolant drain valve. Air dryers. Special types of filter systems that are specifically designed to remove the water that is inherent in compressed air. When air dryer does not function properly, the untreated compressed air, which contains solid, liquid, and gaseous contaminants, can pose a significant risk as it can damage your air system and end product. The associated hazards are similar to those of air receivers, so explosion is the main hazard if safe working pressure has been exceeded, but you can control the risks by preventing exceeding safe working pressure by properly designed and constructed air dryers. Chambers conform with standards and withstand the compressor's maximum pressure safely. Fitting safety valve and pressure reducing valve and install non-return valves to dryer outlet to protect it from stored energy in the system. Mainline systems. Main hazard is related to design, like when machine malfunction by air starvation because of inadequately sized and designed systems. Lack of isolation valves may expose maintenance staff to unnecessary risks or poor choice of used materials, so designers are advised to consult manufacturers when selecting materials. You can control the risks by keeping air system engineering drawings showing details of pipe runs, intended direction of air flow and the positions of valves and drains. Update drawings when modifications or additions are made to the system. Support pipe system and secure by brackets or other supports. Pipe runs should be identified by painting. Isolation valves should be provided. Provide indicating notice of the position and or purpose of the valve. Proper, safe, convenient location of safely locate pipes routes and the position of valves and operating points, specially to persons who will use and maintain the system, not to obstruct access, and representing hazards to persons, should be routed away from any areas where it may be vulnerable to mechanical damage.